Welcome to another deep dive, everybody. This time, we're wading into the world of runoff estimation. How we figure out where the water flows and just how much there's going to be.
Predicting those watery paths, right?
Yeah.
It's super important for, well, everything from making sure we have enough water to drink to designing bridges that don't get washed away.
Absolutely. And this time, we're going deep with a research paper by M. Vamshi Raj. It compares two methods for estimating runoff, the strange table method and the SCS CN method.
Using some real-world data from 3 projects over in Telangana, India.
Strange table, though. Okay, I gotta admit, that name alone piques my interest. It sounds like something out of like an ancient map or, I don't know, maybe a pirate's treasure chest.
Haha, well, it's an older method, developed way back in 1892.
Wow, 1892.
Yeah, but it's surprisingly simple. It basically categorizes areas based on how much runoff they produce. You got your good, your average, and your bad categories.
So it's almost like a gut feeling approach. You look at an area and say, this seems like it drains pretty well. Let's call it good.
Pretty much. And then, on the flip side, you've got the SCSCN method, which is a lot more data-driven. This one considers factors like the type of soil, what the land is used for, and even how wet the soil was before it rained.
Okay, so a lot more variables to consider.
Definitely. And all of those factors get crunched together into something called a curve number.
So we've got intuition versus number crunching. And with Vamshi Raj, he put both methods to the test using a whopping 28 years of rainfall data from those 3 projects in India.
Yep, a whole lot of data. And what he found was actually really interesting. The strange table method often ended up overestimating the runoff compared to the SCS-CN method.
So I guess that means the more complex, data-heavy method is always better, right?
Well, not necessarily. While the SCS-CN method might seem more precise because it factors in all those details, both methods actually showed pretty similar trends in how the amount of runoff changed from year to year.
Huh. So even though the numbers might be different, they're both kind of telling a similar story.
Exactly. But here's where things get even more interesting. The difference in the results, it wasn't uniform across all 3 projects. And that suggests that the accuracy of each method, well, it depends on the specific characteristics of that particular location.
So context matters. A method that works well in one spot might not be so accurate somewhere else. So what did this Vamshi Raj find out about those differences? Like, what kind of locations would favor one method over the other?
Well, it turns out that 2 of the biggest factors were the amount of clay in the soil and how much of the land was used for growing crops during the monsoon season.
So it's not just about the rain, it's about what that rain falls onto. Okay, starting to feel like a real detective story here. We've got to examine all the clues to get the bigger picture.
You got it. And that's one of the reasons why this research is so valuable. It highlights that there's no one-size-fits-all approach when it comes to estimating runoff.
Makes sense. If you're working on a project, like anything to do with water management, you can't just pick a method at random and assume it'll be perfect. You really have to consider all those specific details of the location. Kind of like you wouldn't use a hammer to fix a leaky faucet, right?
Perfect analogy. And this is where the research takes us to a pretty cool aha moment. You see, Vamshi Raj found that a simpler method, like that strange table, it might actually be perfectly suitable in areas with lower clay content and more land dedicated to those monsoon season crops.
Oh, wow. Okay, now that, yes, surprising. I would have thought the more complex method would always be the way to go.
Well, sometimes a simpler approach can be surprisingly effective, especially when you understand the ins and outs of the area you're working with.
So we've got these 2 methods. One, kind of old school, relying on intuition and observation. The other, more modern, all about crunching the numbers. And what's really fascinating is that neither one is automatically better.
Yeah.
It all comes down to like really getting to know the place you're studying.
Exactly, like having a deep understanding of all the unique characteristics. You got to go beyond just the surface level.
Yeah, it's like, you realize your toolbox needs more than just that hammer.
Precisely. And that's what makes this Vamshi Raj's research so compelling, It's a good reminder that even in science, context is king. Just because a method worked in India doesn't mean it'll work the same way everywhere else.
So what does that mean for someone listening in, say, California or, Brazil? Do they need to, like, throw out all the runoff estimation textbooks and start from scratch?
Oh, definitely not. But it does highlight the need to, be thoughtful and not just blindly apply a method without considering the local conditions. I mean, things like soil type, land use, even the climate, those can be vastly different in other parts of the world.
So it's like a recipe, I guess.
Mm-hmm.
You might need to, adjust the ingredients of the cooking time depending on, your oven
Yeah.
or even the altitude you're baking at.
Exactly. Like you wouldn't use a cake recipe designed for sea level if you're baking up in the mountains, right?
Mm.
Similarly, a runoff estimation method that works great in like a tropical rainforest might not be suitable for a desert.
Okay, so besides the stuff Vamshiraj focused on, what are some other things that might come into play?
Well, think about the shape of the land. A steep mountain slope is going to shed water way faster than a flat plain.
Oh, yeah, makes sense.
And then there's vegetation,
Hmm.
a dense forest. It'll intercept a lot of rainfall, while a barren landscape, not so much.
And I imagine the type of rainfall matters too, right? Like a gentle drizzle versus a torrential downpour. Those would lead to very different runoff patterns.
Absolutely. The intensity and duration of rainfall are crucial. A short, intense burst of rain might cause a lot of surface runoff, while a slow, steady rain, well, that might soak into the ground more effectively.
Wow, so many variables at play. It's like a giant puzzle. Each piece influences all the others.
And that's where the real excitement of hydrology lies. It's not just about plugging numbers into formulas. It's about understanding the complex interplay of all of these natural forces and how they shape the world around us.
So Vamshi Raj's research, it's definitely opened our eyes to how much context matters.
Hmm.
But it also raises some pretty intriguing questions. What are some of the things we need to research more to really fine-tune our understanding of runoff estimation?
That's a great question. We've talked about soil type, land use, climate, but what about the impact of, well, us? Human activities. I mean, things like urbanization, deforestation, agriculture, those can drastically alter those runoff patterns.
Yeah, and we can't forget about climate change, right? I mean,
Yeah.
we're seeing more and more extreme weather events, those intense rainfalls or prolonged droughts. How do those affect runoff? Do our current methods account for those changes?
All crucial areas for future research. As we gather more data, develop more sophisticated models, we can start, answering these questions and improving the accuracy of our runoff estimations in this ever-changing world.
Yeah, it's almost like the more we learn, the more we realize how much more there is to discover. Each answer just unlocks a whole new set of questions, and it keeps leading us deeper and deeper into this fascinating world of hydrology.
Exactly. That's why it's so important to approach this field with a sense of curiosity
Yeah.
and a willingness to, challenge those assumptions.
It's amazing, really. You start talking about something like runoff, and it seems pretty simple, right? Like water flows downhill, what's so complicated about that? But then you dig a little deeper and whoa,
Yeah, it turns out to be way more complex than you might think.
right? All these different factors influencing how much water ends up where and how fast it gets there.
It really underscores how interconnected everything is,
Mhm.
from the soil to the rain, even the plants. It's all part of this giant system. And understanding those connections is key if we want to manage our water resources wisely.
Absolutely. So before we wrap up this deep dive, I want to bring it back to our listeners. What's the one thing they should walk away with today? What's the big takeaway about runoff estimation?
I'd say the biggest takeaway is, well, the importance of critical thinking, especially when it comes to data. Don't just accept numbers or conclusions at face value.
Don't believe everything you read.
Right. Dig a little deeper, ask questions, consider the context, like where did those numbers come from? Who collected the data? What are the limitations of the study?
So it's like being a data detective. Got to examine all the clues, check the sources, be skeptical.
Exactly. And that applies whether you're a scientist, an engineer, a policymaker, or, just someone who cares about the environment. We all have a role to play in understanding and managing those water resources.
Vamshi Raj, he focused on 3 specific projects over in India. But like we've been saying, the questions his research raises, well, those have implications everywhere. What are some things our listeners can, ponder on their own as they continue exploring this topic?
Well, think about the unique challenges facing different regions. I mean, deserts, for example, those face very different runoff patterns compared to places that get a lot of rain.
Yeah, and how do things like snowmelt or, glacial runoff factor into the equation?
Right. And what about the impact of human activities, on a larger scale? Like we're constantly altering landscapes, diverting rivers. Heck, we're even changing the climate itself.
So how do we account for all of that? How do we factor in those human fingerprints
Yeah.
when we're trying to understand the hydrological cycle?
All fantastic questions, and they really deserve further exploration. The more we learn and, the more we share what we learn, the better equipped we'll be to manage those complexities of water, especially as our world keeps changing.
So to everyone listening, we encourage you to keep diving deep,
Yeah.
Don't be afraid to get your hands dirty, both literally and figuratively.
Mm.
Explore those local watersheds, learn about the challenges facing your community, and most importantly, share your insights with others.
It's through that curiosity and, that collaboration that we can really make a difference and ensure a sustainable future, both for ourselves and for generations to come.
Well said. That's a great point to wrap up on. Thanks for joining us on this deep dive into the world of runoff estimation. Catch you next time for another fascinating exploration of, well, the data that shapes our world.